This question on gravitational potential looks quite straightforward, but there's a trick in here that most students are going to get wrong. If you want to make sure that that's not going to be you, then you need to make sure you watch this video and save it for when revision time comes round. And you might like to think about joining up to my exam masterclass, where I'm going to spend 15 hours going over exam technique that's going to make sure you get the top grade. £59 for 15 hours. Check out the link in my bio. So let's get going. So we need to work out how much energy is required to move a satellite of mass of 500 kilograms from this point here, A, to point B. So the first we're going to write down is our equation. So work done is equal to the mass multiplied by the change in potential. Now, we know that the equation for potential is V is equal to minus gm on r, where g is a constant, m is the mass of the Earth, and r is the distance. So most students think that then to find the change in potential, we can just do minus gm over the difference in the radius, so 5,000, take away 2,000 to get 3,000 kilometres. But you can't, because 1 over 3,000 doesn't equal 1 over 5,000 minus 1 over 2,000. That is not how fractions work. And this is where we see the biggest mistake in gravitational potentials. Those guys do not equal each other. What you've got to do instead is expand your equation a bit and pop a bracket in. So to find the change in potential, you want to take your GM out, then you want to do 1 over R2, which is going to be 5,000 kilometres, so 5,000 times 10 to the 3, take away 1 over 2,000 times 10 to the 3. You've got your constants written down here for you if you want to try it out on your own in your calculator, but I can tell you, if you pop all your numbers in, you get an answer of 1.19 times 10 to the 8 joules per kilometre. Sorry, per kilogram. Now, we don't want to leave this answer here because we were asked for the energy or the work done. So we're going to use our equation. Work done is equal to mass multiplied by the change in potential. The mass of my satellite was 500 kilograms. I'm going to multiply it by the change in potential, so 1.19 times 10 to the 8, and I get an answer of 6.0 times 10 to the 10 joules. And here's how you're going to make sure that you don't make this mistake and you get full marks on a question like this. So if you want more content like this, don't forget to follow this channel, and I'll see you soon. Take care.